MacMaths. Let's do some maths today. Statistics. Okay, so today, last one of the chapter 3 series. So chapter 3 has all been about representing data, and we're going to finish with this a very quick lesson on comparing data. In fact, you can see what I think about this. You just say what you see. You don't try and be too clever. You don't try and tell a massive story. It doesn't really ask you to interpret. You just say what you see, and you always comment on measure and spread. Okay. This is just a couple of questions in the exercise, and that's all I'm going to do, because we've done all of the data now. We've done box plots, histograms, and whatever else, I don't know, cumulative frequency graphs, and at the end it just asks you to compare. You know, it just has comparing data, and it says there, doesn't it? It says always give a comment on a measure of location. So that is the median, or the mean is what it's referring to there, and a measure of spread. So if you've got data where you've got the median and the quartiles, you comment on the median and the interquartile range. If it's the mean, then you comment on the mean and the standard deviation. The bigger the standard deviation, the more the data is spread out. Okay, so let's just, it's that simple. And let's just, I've not even sort of drawn these out on graph paper because I don't need to. Exercise 3E, if you look at that now, you can sort of see this one. I'm just going to do it straight from here. This first one here, it's got two motorways, and it's got the speeds and of cars that have been recorded on motorway A and motorway B. And if you look at these two motorways, you can see here a motorway A. So, and it says compare the two distributions of speeds on the motorway. Okay, so this is motorway A and motorway B. So in the exam, what would you say? You would compare here, because you've got box plots, you've got the median, and you've got the range or the interquartile range you can comment on. I'll talk about that in a second. Okay, so median for this one, you can see for motorway A is 76 miles per hour, and it's 72 miles per hour for motorway B. Okay, I'm going to do the interquartile range for motorway A, and it's 5 miles per hour, so that's Q3 take away Q1, between 75 and 80, so 5 miles per hour. And for motorway B, it's from 65 to 75, so it's 10. So you can see it's a bigger interquartile range. Okay, so now I've got some data from that. What would you say? Well, you just say what you see. So you would say, comparing them, you'd make a comment on the mean or the median. So you would say on average, that average being of course the median speed of cars on motorway A was larger than the median speed of cars on motorway B. There we go, that's it, that's compared it with a median, 1 mark. Now you can compare the range, okay, or the interquartile range. Now if you compare the range, you can see that the range of speeds of cars on motorway A is bigger than the range of speeds of cars on motorway B, because the two whiskers is the fastest and the slowest car, so it has a bigger range. Okay, so you could comment on the range. You could say what I've just said. The range of speeds on motorway A is bigger than the range of is larger than the range of speeds on motorway B. However, the range, remember, is a little bit unreliable if you're gathering information about data, because this here could just be one car, you know, this slow, and there may not be any other cars going anywhere near this slow. Okay, the next slowest car might be right up here, and this might be one going really fast. So the range here, apart from two cars, might be very narrow, and that's why the mathematicians use the interquartile range. It's considered a more refined measure of spread. It's like on Star Wars, you know, when they use the lightsabers. You know, a Jedi uses a lightsaber. It's a more refined weapon than a blaster. I think Obi-Wan Kenobi says that. So that's what I would use. I would say that the interquartile range is narrower on motorway B and wider or bigger is narrower on motorway A and wider or a bigger interquartile range on motorway B. Okay, and that's it. You've compared the two motorways. You don't have to go into any more. You don't have to make you don't have to try and interpret that. I mean, if you did, the question's not asking that. If you're asked to interpret it, you could say, well, maybe that motorway B is a busier motorway, and because it's so busy and more congested, cars can't travel as fast because they're bumper to bumper and so on. So I don't know. I'm not saying anything now. What I think. Okay, so just measure of spread. That's bigger than that. That's bigger than that. That's all you're doing. Okay, but refer to the words median and interquartile range. Okay, one more. Again, you might be asked to do it. Here you can see boys and girls heights for a basketball club, cumulative frequency drawn on the same graph, and if you were doing that, okay, then they've not given you the data. You'd have to read it off yourself, wouldn't you? Okay, so the girls are in blue and the boys are in red here. So if I did the girls, I'm going to do the median for this one here, Q2, and then I'm going to do Q3 minus Q1. So you'd have to work that out yourself. And there's 80, so you're just reading across from the 40th, and the 40th girl is about 157. Okay, so this is girls and boys, and the 40th boy is 163. So already you're saying that the average, the median boy is taller than the median girl, okay, because these are medians that we're reading off. And then the spread, so it's 80 pupils, quarter of that is 20. For the girls, the lower quartile is 150. And the upper quartile going across from 60 is about 164. Going across the girls from 60 is about 164, 165, 164. So the interquartile range for the girls is 14. The interquartile range for the boys going across from 20 is quartile 1 is 155. And quartile 3 for the boys is 170. Is 15. So don't overplay it there. The interquartile range for boys and girls is very similar. And now I'm a little bit nervous that I've just done it a little bit roughly, so I'd probably double check, or I'd say the interquartile range for boys and girls is the similarly spread out. Okay, you know, they're very sort of similar. Don't say, oh, the interquartile range for boys is, you know, if you say it's bigger, you know, it's only by a tiny bit, isn't it? Okay, so really as a distribution, the distributions are similarly spread out, I would say, but the average boy is taller than the average girl, that average being the median. Okay, so that's enough. There was only 4 questions, and I did 2 of them, the first and the third one. And mixed exercise, you can go through and you can do all of those because it's quite a straightforward. Go back and look at them. There is a challenge question. Let's do the challenge question now at the end of the mixed exercise. And I did write that one out because I thought it was quite a good one. I do like I tend to always do the challenge questions just to make sure that I've got my understanding. Okay, correct. And here it is. Okay, have a go at it first before I shut the door in case the cat comes in. Have a go at it first before you watch the rest of this. But here it is. Okay, so the table shows, there it is, The table shows the lengths of films in a film festival to the nearest minute. So they've been rounded off to the nearest minute. So 4 films are between 70 to 89 minutes long. A histogram is drawn. The bar for the 90 to 99 group is 3 centimetres higher than the bar representing the 70 to 89 class. Okay? Alright, so let's do this then. Find the height of the one. Okay, so here we go. The bar of the 90 to 99, that's that one. First of all, 90 to 99. 90 to 99. Okay, that is 89.5, isn't it, to 99.5. So that has a class width of 10. Okay. The 70 to 89, okay, that's from 69.5 because they've been rounded up to 89.5. So that has a class width of 20, doesn't it? However, it's on a scale thing, so although it's 10, it doesn't mean they've drawn it 10 centimetres long. You don't know how long that is. We do know that this is twice as wide as that one, okay? So let's call that a width of y and that a width of 2y. It says that the bar representing the 90 is 3 centimetres higher than this bar, okay? So let's draw this bar in. There's that bar, and this one is twice as wide, so, and this one is 3 centimetres higher than that one. So let's call this one x and this one x plus 3. Okay. Now we can get two equations, can't we? Because actually we know that the frequency of the 90 to 99 is 17. So we know that that width times that height has to give us 17. Okay. And this one here has to give us 70 to 89 has to give us 4. Okay. So now we know that length times width, so that is y times the x plus 3, has to be 17. Has to be the frequency, which is the area, as 17. We also know that 2y times x, so 2xy, 2y times x would be 2xy, has got to be equal to an area of 4. So we've got two equations and two unknowns, so it should be easy to solve. Multiply this out, and y times x is xy, putting it the right way around, and y times 3 is plus 3y, is equal to 17. And we can simplify this one, can't we? Divide both sides by 2, so we know that xy is equal to 2. Now if xy is equal to 2 from this one, we've got that information from this bar, we've got an xy there, and we know that is equal to 2, because the whole thing is in the same scale, isn't it? So 2 plus 3y is equal to 17. Take 2 off both sides. 3y equals 15. So y must be 5. Okay, so we know that y is 5 now. Now if we look at the 110 to the 139 class, the 110 to 139, 110 to 139, well that is 109.5 to 139.5, that is 40y. 40 wide, isn't it? Okay, that bar. And it's twice as wide as this one, so it's 4y. But we know that y is 5. We know that this had a width of 5 and that had a width of 2y, which is 10. So this is going to have a width of 20, isn't it? That from there to there, because it's 4y and y is 5. Okay? And we know, okay, that its area, because it is 100, is 9. Okay, so 110 to 139 has an area of 9. Okay, because its frequency is 9, and its class width is 20. Okay, so 20 times what is 9? I've done this right, 9. Yeah, okay, so therefore the height of this bar, hold on a minute, I've done this wrong here, haven't I? 109.5, 110, 119, 120, oh gosh no. So that's 30, so that's 3y. 15. I'm having a laugh here. Okay, so 15, yeah, so 15 times this height gives you 9. Okay, so 15 times the height is equal to an area of 9, so the height is 9/15. Okay, so the height of this bar is 9/15. I think it said in the back 0.6. 9/15. 9 divided by 15 is 3/5, which is 0.6. Cancels down, doesn't it, to 3/5. Okay, centimetres. There we go, and that is the right answer. Sorry about that. I couldn't take away basically 140 from 110 from 140 and get the right answer. Okay, so there we go. I am 53 now, I'm getting old. Okay, so that's chapter 3 finished. That was a good question, that wasn't it? I enjoyed that, even though I always did it wrong. Okay, over and out.